we have few calculations related to electrolysis. One is Q is equal to IT, charge is equal to current, units ampere times by second, or N is equal to Q over S. F. N is mole of electron, Q is charge, F is Faraday. Okay, right. So we need to use the stoichiometry of the reaction to find the mole in the element. So whatever it is, when you have one element or compound, you have to come out with reaction first. Find the equivalent reactions, stoichiometry reaction at the end in order to find the mole. How many equivalent of the coefficient is. Okay, right. And then mole to gram of the compound. We need to know this by conversion as that. From a current, we want to find this one. Okay. Now, first calculate the charge through the cell in the 12.2 minutes. So charge is equal to current times by time in seconds. So current is 0.15. Time is 12.2 minutes. From minutes times 60 seconds, you can get second. So that will give you charge of column. Okay. From column, how do you find moles? It's time by 1 mole over Faraday, 96,485 column. Okay, so this one column, that's why we put down here, because we want to cancel the column here. Okay, we want to find mole. Right, you cancel the column. Okay, so what you got is 1.138 10 minus 3 mole. Okay, from mole, what we should do is to find the gram, isn't it? So before that, we have to find N first. N, calculate the amount of nickel in gram, and we know it's 2. How do we know it's 2? Nickel 2 plus, nickel 1 is released or adding up with 2 plus of electron to become nickel 2 plus, right? So the equation is 2. Right, so this one is the mole just now, times by 1 mole over mole of electron. So we want to cancel this one, so you put down here. Okay, this one 1 mole nickel times by molecular weight 58.69 gram of nickel over 1 mole of nickel. So this one is cancelled out as well. So what you got in the end is a gram. Okay. Okay, we can also do the entire calculation in one step. So for example, from current ampere times by minutes, convert into second. From second times by 1 mole over Faraday. Okay, from that we can cancel the column. This is what we give you column. Okay, so over column and then cancel with 1 column over AS. In the end, you got 1 mole over 2 times by 56,000. Alright, gram nickel over this one. See, this is quite tricky. If you don't know this root, just take it one step by one. Okay, right, so you got 0.033 gram of nickel. Mass to mole now. Okay, from mass to mole. So we got 2.5 gram of silver times by 1 mole over molecular weight times by 1 mole over 1 mole. That will give you this one mole of electron. So what you need to do next? You have to find, right? Okay, mole times by Faraday over 1 mole to cancel the mole times the column. Okay, 22.36 column. Now you have reached to this step. Once you got column, you can find mass, time or current, right? So time is equal to charge over current. So 22.36 over ampere times by 1 ampere over 1 column. Just to cancel, and then from that change it into second, from minutes to seconds. So you got this one. Okay, 46.6 minutes is okay. If you want to state answer in second, it will be a bit banyak kan kat situ. So we just put it in minutes, is fine. Okay. Okay. So we can do this one in the entire calculation like this as well. From gram, change it into mole. Okay. From mole, you divide by N. Then you times by Faraday over the column and ampere, and then to the minutes. So you can get the minutes. Okay. Alright. Okay, this is another example. You can try by yourself. Okay. Right. If you're given Ca2, CaCl2, so this is the equation that you have to find first. So from that you can get the N. Right? Then settle up. You can get the mass is like this. You can always come here and do it slowly, one by one, step by step. Okay? Right. This is another example. What is the current needed? Okay, so from this one, from mole, okay, over gram, so we can get mole, mole time by column, so we can get column, from column change it into minutes, okay, you can get per second, and current, yeah, all the equation that you can always come through, right. So now, I will go with application of electrolysis and battery. Battery, okay. So, actually, electrolysis can go application either in battery using galvanic cell or electroplating or in electrolysis in action. Okay, so you can look at two major classes of battery. We have primary cell or secondary cell. Primary cell is a cell that cannot be rechargeable. For example, we have triple A battery. That is not rechargeable. But if you have a triple A battery that can be charged, that we call it as secondary cell. So secondary cell is rechargeable. It have plumbum storage lead battery, which is normally is very resist to high temperature, like car. Okay, so type of battery, we got alkaline battery. Alkaline battery is made up from zinc or manganese oxide battery. Right, you use basic alkaline. It's not rechargeable. It's compared to dry cell. It has a longer shelf life. It delivers higher current. It is less expensive. Okay, reaction in anode and cathode. What happen is zinc react with hydroxide. You can got zinc oxide and H2O. Okay, 2 electron has been lost here. But in cathode, simultaneously mangan receive 2 electron and H2O to balance it. Alright, so what you got is mangan trioxide and 2OH. So this is the overall equation. Zinc plus 2 mangan oxide produce zinc oxide and mangan trioxide. Okay. Okay, this is the part where you should know if you have the alkaline battery downwards, it's normally anode, negative sign here. So it's made up from zinc powder, while cathode normally pointed upwards. So you have like positive sign or a bit bumpy here, positive side of mangan oxide and KOH electrolytes. Okay, right. So nickel battery, nickel cadmium battery, it have 1.4 volt. Just now it's 1.5. This one a bit slower. Alright, so rechargeable. It is rechargeable. It means that this is a secondary battery. It has high energy density. It's release energy quickly. It's rapidly charged. Used portable for power tool, CD player, electric cars. Okay, the reaction is involved cadmium on the anode, nickel oxide on the cathode, and this is the overall charge. Okay, so what is the advantages of this kind of battery? Cadmium is toxicity, so it's gonna create a disposal problem, especially towards the environment. Okay, we can't just throw our nickel battery just like that. We have to throw it in proper way. Okay. And then nickel MH ataupun metal hydride battery. This is rechargeable, also like secondary battery. It has 1.35 volt. Okay, it does have some metal and alloy. We can absorb hydrogen gas effectively. It store and release the redox reaction. The advantages: 50% more power and volume than nickel cadmium. It has can be used longer compared to nickel cadmium just now. So what is, we have metal hydride here, react with hydroxide to produce metal and H2O, and then this one is nickel oxide plus H2O. This is the overall net equation. So this is the what we call the diagram of the battery itself. Okay. Alright, the most important properties of the battery. Battery mostly we know it being considered in many applications such as in our phone, handphone, laptop, digital cameras or cordless tool, and also pacemakers and anything, many things that involve the batteries. So what are the important properties of the batteries? Are its shelf life, which is how longer do the battery hold the charge when it's not in use. Is it easily to be consumed or not? Alright, the rate of energy output, is it produce high current or not? For example, if you have a battery, you have rotating these devices such as a face cleansing, okay, face cleanser, which is it has a battery inside it. So is it produce high current or not? Is it effectively can clean your face or not? Okay, energy density, ratio of the available energy to battery volume. Right, and then specific energy ratio of available energy to the weight. Okay, how much the weight can produce energy? Is it too weak but it produce less energy, or how? Okay, those are among the properties of the battery that you have to take notes if you want to consider to buy a. Okay, when we talk about battery, we are normally related with lithium-ion battery. Basically, has been used many in our laptop, for example, or smartphone. So lithium-ion battery is rechargeable with high specific energy due to the low mass. Yes, this is how is it. It has low mass, but it does provide very high specific energy. The high energy density is very negative. It's very negative, don't actually involve through oxidation and reduction. Lithium, however, it can slip between layers of the atom in the solid such as graphite and lithium cobalt oxide. This is process called as intercalation. So lithium ion battery is based on transport of lithium. This is how your lithium ion look like. Alright, so when it being charged, so basically electron is moving from here to here, but from positive to negative. But if not being discharged, okay, recycle, so it's actually from negative to positive. Alright. In uncharged state, so no lithium ion in graphite, but when we charge, lithium ion leave the lithium cobalt, travel through the electrolyte, okay, from here to here. This is the lithium cobalt, right? Okay, so if not being charged, it's not moving over there. This one is moving from here to here, right? Okay. The other application of electrolysis can be seen in a fuel cell. Fuel cell, basically, it's like kind of battery, but it have a huge impact. Okay, it's much more larger and it has more powerful power source compared to battery. Okay, so the fuel cell is able to operate as long as the supply of reactant is maintained. It can be used for long-term generation of electricity. It's more advantage. For example, it produces clean burning. It's no electric loss, easily to replenish. It produces high operational temperature and also highly efficient. Okay, this is an example of hydrogen oxygen fuel cell. Okay, in the early design, we designed oxygen with the H2O, okay, and then anode is hydrogen with the OH. The net equation is here between hydrogen and oxygen only to produce H2O. This is where normally involved in water generator. Okay, from hydrogen and oxygen is produced H2O. Alright. So basically the electrolyte itself is a hot electrolyte which is more than 200 degrees concentrated one. Alright, for example KOH electrolyte, okay, here, and then it contact with two porous electrode containing platinum catalyst that facilitate the reaction. It can't go by itself. For example, hydrogen is being inserted in here while oxygen is being inserted here. Somehow it needs some kind of catalyst in order to regenerate the current. Okay, and then the advanced LED to lower advanced LED to lower the operation temperature of H transfer membranes. Okay, this is kind of another application of electrolysis is in electroplating. Electroplating means that you plate your existence of metal, okay, with something else. Okay, electrorefining is a purification of the metal by electrolysis. Something that are not being purified now is being purified using the electrorefining. By electroplating, we coating one metal of the surface with another metal. So, for example, coating process will protect from corrosion. Okay, for example, this spoon. You want to turn this silver spoon into the gold spoon, for example. So what you do, you plating this silver spoon with gold plate, for example. Towards the end, every surface of this spoon, silver spoon, will be turned into gold spoon here, like here. Right? So this is very effective. Right. In the purification, for example, we want to impure this one. We got two electrode, pure and impure copper. Okay, so what happened? This impure can be purified. by using pure copper. Alright, the impure copper is made of anode, while piece of pure copper is the cathode. So reaction with copper, it happen here is process of displacement of this one to this one. Okay, right. So overall change is transfer pure copper from the anode to the cathode. The impurity will be less reactive than copper. Right. Any question, you can always come back.